Well, good morning, good afternoon, and good evening, everyone. Welcome back to day 2 of the GS for Sustainable World Conference. My name is Ryan Langcloss with Esri, and with me today is my colleague, Olivia Cottrey. Good morning, Olivia. It's good to see you.
Good morning, everybody. Good to see you again.
Well, welcome back. We are so excited to have you with us for day 2. What an amazing day 1, just for a minute, if we reflect, Olivier, just looking back, to hear Dr. Tedros from the World Health Organization, the Director General, talk about their amazing response to this global pandemic and really more global health emergencies in general. So not just this pandemic, just tremendous amount of work being done. I just want to recognize our opening speakers from yesterday that really set the context for this whole event. This theme that we have of enhancing response and resilience really focused on response yesterday. General thoughts you have from yesterday's opening and what you saw throughout the day?
Yeah, absolutely. No, for me, it's just great in general to see, I think, how we as a community are really starting to leverage GIS for operational management and analytics. So we saw this, like you said, in the amazing work that INSARAG has been doing, ICRC, FAO, WFP. And we can see that we've just really moved on from the simple mapping, that the PDF map of a few years ago, to focusing on, well, I think the S of GIS, right? The systems of GIS. Yeah. So really using GIS now for coordination and for operational management of teams, and so delivering solutions that have very direct and concrete impact on response and affected communities.
Yeah, I think that's great. I love the S in GIS, pulling that forth. I think, yesterday when we did this opening, my colleague Einar Bjorgo from Unisat, who's our co-organizer for this event for the last 10 years, we really talked about the evolution and use of GIS. And I think it's hitting on what you were really bringing forth, is that we saw a tremendous amount of work yesterday that was, beyond just, basic mapping and showing just points on a map and just providing context, but really understanding, if I would to translate that a bit, right? It's the evolution of GIS to more than just a map for GIS professional, but really a tool that helps decision makers at all levels to help truly make direct impact in operations around the world. I really appreciate that you called out a lot of the great presenters in the lightning talk section yesterday that really brought forth some impactful solutions for the community. And it's funny, if I reflect on that, I think that shift, right, there's a couple of reasons maybe why that's happening. Part of that is the evolution in technology that makes it easier to launch solutions, for example. Maybe there's some things there we want to pull out. But I'm also, very cognizant of the fact that it takes deliberate work and action to make that happen, right? We have a session later today on this idea of user-centric design, right? It's building solutions, deploying GIS at scale for an organization, ensuring that the tools that we're building help solve real problems. And we saw that in action yesterday. Any thoughts on that from your side? Your actually background in this, right, coming before Esri, was really driven by this understanding of user-centric design. Just thoughts?
No, that's right. And you touched on it, actually. I think the big game changer of the last few years has been this ability for us to easily configure and reconfigure and reconfigure very intuitive tools and applications. And that allows us to really engage stakeholders of GIS, and not just the GIS technicians, but the stakeholders, the final users of the information of GIS, that GIS produces, into the conversation, into the actual design and implementation process of a GIS. So it's a much more interactive approach now to set up a GIS that really brings in non-traditional stakeholders, so not the technicians, but the operations managers, the program managers, because they can see these tools being built as we talk, and that's a real game changer in systems design. Absolutely.
Yeah, I like the way you just said this iterative process, right? The ability to sit down with a decision maker, an operations person who's working on a program or deploying people to the field, and thinking about how we do that well, and actually being able to watch the tool in real time, in fact, get configured, get reconfigured, as you put it, over and over till we find the right workflow that supports the need and doesn't overwhelm the other audience, right? I think that's really interesting, this evolution. So I'm excited to hear more about that today from the session and our speakers. We're going to hear a number of organizations come together to talk about how they've done that inside of their organization specifically. So certainly, tune into that section later on. And I was excited, just kind of coming back to day 1 a bit too, hearing from Loretta from UNDRR talking about systemic risk, right? The need to look beyond what's in front of us, just the natural hazards that we're often focused on, or the sudden onset emergency, if you will, to really understand the integrated nature of risk of both natural hazards, right? The built environment, the population that we serve, the demographics at play, like all of that, really truly understanding what it means to be resilient and truly make sustainable change in our community. I would say, you know, while yesterday was certainly focused on response, right? That was intentional for us. Today is taking the shift now into talking about resilience. That is, you know, looking at how we get out of the response mode that we're constantly thrust into in this community, it seems like over the last 5 to 10 years, and continues obviously to take our main attention. But what does resilience mean to you, Olivia? I'm kind of curious, like, again, coming from your background into this, it could mean a lot of things for an organization or even a community. I'm just kind of curious your thoughts there.
Yeah, I mean, I think resilience is the area where I think we've got the most to learn and the most to develop, in fact. So, I mean, like you say, I think it's well accepted that, you know, this sort of purely response-driven humanitarianism is not efficient, it's not sustainable, and a lot of effort's been put into this upstream reduction of risk and mitigation of risk, and supporting communities and increasing their resilience and their own ability to respond and to recover. Yeah. Which also means fully acknowledging that response should be as local as possible and global as necessary. I think we've heard that expression quite a bit now. So now the question is, how do we support that with GIS? What's the best way to do that? And I think it means thinking about GIS in quite new ways than we've been used to so far. So rather than focusing, for example, on answering the where is or the where was question, which is typically what we would answer after an event has occurred. I think we can really start to learn and exchange and discuss how we can think more about the where should and the where will questions, you know, so that communities can use GIS to build models and scenarios that inform them on the risks that they face, that provides them with actionable solutions to reduce those risks. So there's a part of what we call geodesign. So you might have heard that term, geodesign, and I think we really want to start looking at that some more. I think there's an enormous amount of potential there to help the humanitarian effort. And we'll be seeing a few examples of those today during the lightning talk. So those I'm really excited about.
Yeah, I appreciate you kind of pulled forward this geodesign concept. I mean, I think, you know, resilience, you know, the idea to bounce back in the face of whatever hits us, right, is one aspect, but I think it's like making the hard decisions on the other side of that equation to make change in the built environment, to make change in the policies and the way that we respond, and also to make sure that we have capacity to do that, right, at the local level, and leveraging that local expertise and building that up and investing time and effort. So it's not just the global community, it's truly all of us together, right, contributing at all levels to this resilience. And geodesign is an important part of that, right? And we're going to see, as you mentioned that, and even on the plenary yesterday, you know, Jack referenced the Aga Khan habitat group that's doing some amazing work in Central Asia, right? Looking at local vulnerabilities in a community to then, how do we mitigate that, right? What are the risk reduction strategies with which we can put forth in a community to truly have lasting change? So I really appreciate that we're trying to now shift focus for today into that more resilience thinking, right, forward-looking, anticipatory action to get in advance of just being in response mode and reacting to what's in front of us. I'm excited about today and some of the speakers we've got in front of us. I'm also excited, I think, today as we now start to look forward into the agenda a bit, that we're going to take a bit of deeper look into the technology side of GIS. So truly looking at how these tools that we've been talking about and the solutions that we've been talking about can support not only the response to the sudden onset or the crises around us, but start to build that resilience. We're going to see a bit about this global geospatial infrastructure that Jack Dangerman, our president and founder at Esri, who was on the keynote yesterday, talked about. This idea that around us is this infrastructure that can connect us together, enabling that local community to interact with regional and global actors all together in a simultaneous way to better understand risk, the needs of the community, and truly move forward to build this sustainable and resilient future that we all know we need. And certainly, you know, an undercurrent to this event is this nexus of climate change, you know, driving weather, driving impacts that are certainly more impactful and more hurtful than ever before. Certainly looking at how those crises then lead to destabilization and actually, you know, peace building longer term. And so I'm excited to hear that come together looking this morning beyond this. So I just say, before we get to that part of it, finally, I guess what I'm excited about today as well in this idea is that we're certainly here for 2 days together. I appreciate that this global community, again, the largest audience we've ever had, globally able to come together, this diversity of thought that we're having. But it's more than just about these 2 days, right? It's about how do we move forward? And I think that's kind of pulling out that resilience thread a bit more too, right? It's not just in this moment of today and yesterday, but truly what do we do tomorrow moving forward? And so we've got a couple of things on the agenda today that I'm excited to hear about. Certainly there's a mapathon with our OpenStreetMap partners looking at COVAX efforts. And then you're going to be talking a bit about the Humanitarian GIS Hub. So any thoughts, anything you want to kind of tease up today for the agenda?
Well, I don't want to give away too much, but yeah, no, very much looking forward to showing you around the Humanitarian GIS Hub, which we've been developing over the last few months. We're really hoping this becomes a tool and a vehicle for this collective learning, an exchange of best practice around humanitarian GIS. So like you say, Ryan, really to take this forward, not just have these sort of punctual moments in the year around these conferences, but have an ongoing conversation and have this space for us to structure that conversation. So we'll be showing you the hub, the way it's organized, and what we're hoping to get out of it, and how we're hoping to be able to exchange and engage with everyone using it. Yeah, and like you said, also the mapathon. So that's more of a, in the next few days, we're going to be running a mapathon. So join us for the briefing on that at the end of the day. You'll hear about some of the ArcGIS tools that you can use to contribute to and use OSM data. But you also get a training session from the Humanitarian OpenStreetMap team, the HOT team, for a crowdsourced mapping project that will run over the next week or so to help with data readiness for the global COVID vaccine distribution program. So a really exciting way to finish off the day, I think.
Yeah, I agree. What an amazing time. So, I love that we as a community can contribute together from wherever we are in this conversation moving forward from today. So, well, before we get to that, what happens tomorrow, let's talk about today again. And really, I think it's time for us to transition into the morning opening plenary. We're going to talk much more technical today. And so I'm excited to be able to introduce our colleague here at Esri, Brendan O'Neill, who's the lead account executive for nonprofits and global organizations, along with our colleagues, Rami Aluda and Adam Pfister, who are going to be talking about this geospatial infrastructure in action. We're going to see a lot of the technology that was alluded to yesterday and you've seen through lightning talks, but really looking at a global emergency that's underway today, how we can apply things like geospatial machine learning, geo AI, looking at field mobility and tools and the like to bring people together and respond to what's in front of us. So without further ado, let's turn it over to Brendan and we'll see you back later today for more. So enjoy this morning. Thank you, everyone.
Hello, and welcome to day 2 of our 2021 GIS for a Sustainable World Conference. My name is Brendan O'Neill, and I'm part of Esri's nonprofit and global organizations team, which is a team that's dedicated to helping organizations like yours do your work better through applied geography. We hope you were able to take in some of the sessions yesterday, the keynote speakers, community lightning talks, as well as the technical workshops. Don't worry, there's going to be more of that content later today. But right now, what I wanted to focus on in our technical plenary is presenting some of the new innovations that are coming out from our Esri product teams that can help us build resilience and better understand, plan, and act in our humanitarian responses. Our keynote speakers mentioned yesterday that our world is facing increasingly challenging, complex, interconnected problems. And if we have any hope of addressing these problems, we're really going to need to evolve our tool set that helps us better understand the world. So today we're going to be talking about some of the advances in GIS technology that enable us to do more advanced analytics and gain insights, as well as share information and connect stakeholders so that people are all on the same page when they're responding to these crises. And we're going to be presenting this information through the lens of the desert locust crisis. Desert locusts have been a problem for centuries. They're undermining the lives and livelihoods of agricultural workers and pastoralists. And the FAO has been doing a great job of working with local and national authorities in mitigating the impacts of these locusts. But the threat they pose persists. And one of the issues around desert locusts is that in our responses, we're often dealing with prolonged crises, as well as needing to in parallel, work on different parts of the response cycle. So we're often doing preparedness activities, we're responding, as well as doing recovery operations, all at the same time at different locations where the locusts have been. So that creates some pretty unique challenges that we think that we can use GIS to better understand and understand these crises and react accordingly. So what I'd like to do in this first segment is introduce my colleague, Rami Alauda. Now, Rami's going to be showing us some really exciting tools that are in ArcGIS Pro. He's going to be showing us some of the latest in Geo AI and the deep learning integrations that are there in ArcGIS Pro. And he's also going to introduce us to a new web application framework called ArcGIS Experience Builder. So for some of you who are familiar with our web app builder framework, Experience Builder is an evolution of that concept and allows us to build these interactive web applications without writing any code. So without further ado, I'm going to turn it over to Rami so that he can show us some of his spatial analysis workflows as well as ArcGIS Experience Builder.
Hello, everyone. This is Rami Aluta. I'm a solutions engineer working with Esri out of our Rotterdam's office. I do support global nonprofit organizations along with land administration organizations. Today, we're going to be exploring some desert locust data along with other publicly available data sets in order to understand the effect of desert locust through geospatial data analysis workflows. We're going to start our journey with ArcGIS Experience Builder to learn how to tell stories and how to present our work. Then we're going to move into the details of the workflow and learn how to work with deep learning in ArcGIS Pro, then move to spatial analysis and data visualization within ArcGIS Pro. The end goal of our demo today is to detect locust breeding sites or potential locust breeding sites along with agriculture areas that are highly likely affected by locusts. After this brief intro, we are ready to move to our demos in order to get some hands-on experience on the workflows adapted to understand the effect of desert locust invasion. As mentioned, we will start our journey with ArcGIS Experience Builder. ArcGIS Experience Builder empowers you to quickly transform your data into compelling web apps without writing a single line of code. Build map-centric or non-map-centric apps and display them on a fixed or scrolling screen on a single or multiple pages. What you're seeing on the screen is actually an experience that I created to showcase the workflow that we did with understanding desert locust effect on bare agriculture lands. In this experience, we're going to start with the different steps that we took in order to reach the end result that we're looking for. We're going to start with our training data set that you see on the left side, which is a pre-prepped data set that was used to train a deep learning model in order to inference our raw input Sentinel imagery that we got from ArcGIS Living Atlas, and we'll see that in a bit. Then the QA/QC workflows that we worked with in order to come up with the best possible results out of the deep learning workflow. After going through the deep learning workflow through different iterations, we were able to get the inferenced agriculture lands, divide them into different years and different dates, intersect them with a baseline, and come up with the affected lands through our dates that we're trying to understand. The next step was to summarize this data through some hexagons and performing some spatial analysis, and we will get some hands-on experience on that as we go through the experience and the workflow. Then how can we join these lands into the locust data that is made available through FAO, ArcGIS Hub, and finally how we come up with potential areas that are likely to be affected with locust. This workflow is detailed through this experience, and you can certainly check it out later as we'll share a link to this ArcGIS experience. As I explained what is the high-level workflow, I'm going to be going down to get a brief sneak peek of what are we going to be showing today. So we'll start with 3 dates between Jan and March 2019, 2020, and 2021. We're taking 2019 in our area of interest, which is the Rift Valley of Kenya, because there was no desert locust reported at that time. Then we're going to see the desert locust reported in the assigned dates in 2020, and the same for 2021. This data is directly coming from the UN FAO Desert Locust Hub. The next step is understanding the agriculture or the bear agriculture trends within our dedicated dates. So what we're seeing on the map is bear detected agriculture. This was inferenced through deep learning models, a deep learning model that I actually trained on my machine with the training data we saw earlier on in the map. We inferenced 2019, 2020, and 2021, and we got a general image on how is the bear agriculture trend within our area of interest. The next step of the workflow was moving to spatial analysis and understanding those bear agriculture lands that didn't exist in 2019. Because there was no reported desert locust in 2019, it means that that can be our baseline. That can be the place where we start and we say that within this season, there was no agriculture happening or there was agriculture in these different fields. The ones you see highlighted in 2020 and 2021 with the red color, these are detected agriculture lands that are bare at that time as they're not planted and they didn't exist in 2019. So this is a good starting point to figure out that there's something wrong happening in there and there is more bare agriculture land. The next step we try to do is spatially join those detected agriculture lands to hexagon bins that we created. Those are 5 square kilometer hexagon bins across our area of interest. And we can see that I'm highlighting those that are reporting high agriculture practices and a lot of agriculture fields detected there. So I joined the area of the agriculture field and the count of agriculture fields within each hexagon in order to come up with a clearer image of what's happening in there and to detect some high likely areas that are having a lot of change in the agriculture practice. The next step was trying to understand the direct effect of locust on these bare agriculture lands. And for that, we need to figure out where are these agriculture lands. So we cross-reference the bare agriculture lands that we got into the hexagons. And then from the hexagons, we created a buffer around the swarm data that we got from 2020 and 2021 and intersected that with the hexagons. That way, you're seeing some highlighted hexagons from 2020 and 2021, and those are the high likely to be affected or had been affected by the desert locust swarm. Finally, we wanted to get a forecast estimate on the count of people affected through the desert locust swarm, and to do that, we already have our high likely affected areas. We just want to know how many people are living in there. And for that sake, we got the Facebook HDX data, intersected it with these polygons. And as you can see, within 2020, the range of people per hexagon vary from 20,000 to 50,000 to 72,000. And the same for 2021 from 430 to 11,000. These numbers will add up and we'll get a clearer image of the amount of people or the size of people that were affected by the desert locust. Finally, on this section, I'd like you to scan this barcode because this is a publicly available experience and it's a great place to start from and learn how can you create and share and tell stories within ArcGIS Experience Builder. That said, we are now ready to move to our data sets, explore them, and figure out how to work with the data analysis and deep learning workflows in ArcGIS Pro. Now, as we're ready to explore our data sources, let's go to UN Locust Hub. This is a place where you can find a lot of data and information products around locust. We are mainly interested in the desert swarm dataset. So I'll hit explore dataset. That will load the page of the data where I can examine the data extent, examine the fields of my data, have an overview of the data, and certainly export it. I'm interested in the geo service, so I'll take this URL and import it to my ArcGIS Pro in order to use this data set and filter among the dates that I'm looking into. The next was the Sentinel dataset, which I used for inferencing and for deep learning. That Sentinel dataset is available through ArcGIS Living Atlas of the World. You'll only have to type Sentinel and you'll see it in here. If you click the dataset, it will take you to the dataset page where you can learn more about the bands of Sentinel, the components of it, the resolution across the different bands that exist and the wavelengths of these bands. Finally, with the Facebook HDX data, Humanitarian Data Exchange, I already filtered Kenya high resolution population density map, and it is available as a CSV and as a GeoTIFF. I've exported this GeoTIFF, which I worked with later on in ArcGIS Pro. Now, since we've shared our data sources, we're ready to move to ArcGIS Pro and learn more about the workflow that we've done. As we learned about telling stories with ArcGIS Experience Builder, along with our raw input datasets, we are now ready to move to the next stage of this demo, deep learning workflow and spatial analysis and data visualization. For the spatial analysis, I used the Kenya Sentinel image in order to train the deep learning model that will detect bare agriculture lands. For that, I've used the training data set that you're seeing here, and this is consisted of 6,600 features. This was enough to reach a 70% accuracy model. In case I'm looking for more, I need to add more input data and iterate and retrain this model in order to increase the accuracy. What I mean by that and by the iteration, we can view that in the catalog view. If I go to my folder, I have my training data here, and these are the 11 batches. In the images, I do have all my chips, and the labels exist in here, which is under soil. The next thing I'd like to show is the deep learning models, and that's also 11 iterations, and I've reached the 70% accuracy with iteration number 11. This is essential in order to get a better results with deep learning. Going back to my imagery, I tested the deep learning model over the detected bare agriculture, and that's what we're seeing in here. If I go to my map, go to my bookmarks, I'm able to zoom in into an area and see that the model is actually doing well on detecting bare agriculture lands. It needs more training, and as I said, this is more iterations, but for the sake of this demo, this can deliver the idea that deep learning is able to detect features that I train it on. As I'm done with prepping my model, I'm ready to go into the next stage of deep learning, which is inferencing. For that, what you're seeing on the screen is the inference data set from 2021. I've done this over the different years. You can see the swarm data is in there, and all the inference features from March, Feb, and Jan are in my screen. The other thing I want to show is 2020, and that's also the bare agriculture lands classified over the 3 months with the swarm data. I've used 2019 as a baseline because whatever is detected here is known to be there as bare agriculture land, and there was no swarm reported back in that date. As I'm done from the deep learning, I'm ready to move to the spatial analysis side. I'm going to start to try to pick up these features that might be affected by the desert locust. I've already merged all my layers from each month in the year. So I have 2019 in here, and then I have 2020. If I select 2020 and I go to my appearance, I'll be able to turn on the swipe tool, and you're going to see that, yes, the purple features are newly detected features, and they are stuff that didn't exist in 2019, or there's some of them that didn't exist in 2019, which might highlight the idea of, yes, these might be affected by the desert locust swarm. Also, the same for 2020. So if I turn off 2020 and I turn on 2021, I'm able to see that, yes, the same thing is in there, and there might be a couple of features that didn't exist in 2019. To do so, I've used the intersect tool, and I was able to highlight features from 2020 that didn't exist in 2019, and the same for 2021. By that, I have a clearer image of those fields that might be affected by locust, and I want to push this spatial analysis into a further investigation. And that's where I'm going to try to size the effect of the desert locust. For that, I started with agriculture hexagon bins. So I created a mesh of hexagons across my area of interest. Each hexagon of these is 5 square kilometers. The next thing I did is I spatially joined the data of the inference agriculture fields from 2020 with these hexagons. So if I turn that on, I'm able to see hexagons that are symbolized with the bivariate symbology, which combines two fields, the join count of fields per hexagon, and the area of fields. And I'm mainly interested in those dark colors that exist around here because these have at least 25% of the area of the hexagon with bare agriculture that is new from that year. And there's a good count of bare agriculture fields within the hexagon, and I'm looking for 5 fields plus. The next thing I've done is I've added the swarms data and the buffers around the swarms data. This will enable me to select those features that overlap a swarm area and they might be more likely affected by swarm. That done, I was able to highlight these features that I told you about, which exist in the hexagons areas. These features are agriculture fields that, as I said, have more than 25% of their area within a bare agriculture classified field. And I've done the same thing for 2021, and I can already see that I have a little bit less agriculture fields, and that's mainly due to the movement of the swarm and not passing through agriculture fields. It's more dictated around the topography of the area and the areas that swarms moved in. As I got a clearer image of what's happening and where are these agriculture areas, I was able to intersect these features and get the affected areas which we saw and get it into the next stage of the data, which is trying to size the population estimate that was affected by the agriculture swarm. For that, I've used the HDX population estimate, which you're seeing in here. And then what I did is I got those highly affected areas and intersected them with the HDX data, which gave me an insight of the amount of people or the size of population that is affected by the desert swarm locust. The same for 2021, I'm able to size these affected people and actually know how many are within each area, which will make further jobs much easier because we're already downsized from a 10,000 square kilometers to a couple of square kilometers within our area of interest. As we're done from this workflow, we're now ready to learn more about locust breeding suitability analysis. For that, I've used the global soil moisture layer along with the sand quality layer and the greenness layer across Africa in order to find out the most suitable areas for locust breeding. To do so, I've utilized raster functions in ArcGIS Pro, where I've created a raster, an output raster that's built on top of the 3 inputs, where I remap the values for these that fit into locust breeding areas. And for that, for instance, I'm going to check the sand, where I highlighted areas between 550 and 751 grams per kilogram of soil. Those are the highly probable for locust breeding. As I done the same for the other layers, I came up with a final layer, which shows me the suitable breeding areas across my area of interest. The values in one are less probable, and the values in two are the high probable areas for breeding. I was able to extract these as polygons, and add in the swarms data from the end of March in order to figure out where might be those high suitability areas for breeding. And I already can see in my map that those are the closest, and there might be something happening here. So that's an area of interest where locusts might get there and breed. To see so, I can zoom into my bookmark and I can have a closer look around the area that the locust might breed in. I hope with this you've learned more about the detailed workflows that we can perform within ArcGIS Pro or ArcGIS Online with Experience Builder. And now we're ready to move to our next step in this demo. I'll handle back the stage to Brendan, and thank you all for attending this.
Thanks, Rami. It's amazing how you were able to use ArcGIS Pro and the data coming from the Locust Hub to train your deep learning model directly in the application, and then bring that model back into ArcGIS Pro once it's been trained to apply on that Sentinel-2 data. It's really interesting. I think it's going to be a game changer for our GIS professionals and data scientists alike. Now that we have an understanding of where the locusts have been through Rami's deep learning analysis, as well as where they're likely to be through that predictive raster analysis, let's change gears a little bit and discuss how we can use GIS technology to better plan our response activities. And we're going to do that by showing you a few familiar technologies and perhaps some new ones that you aren't as familiar with. Adam Pfister is going to be up next. He's going to show us how he's used ArcGIS Hub to implement a localized engagement platform. These hub sites are really easy to put together and stand up, and they facilitate sharing of information between local responders, humanitarians that have been deployed there with the community through things like web maps and apps. But importantly, they also provide access to community members to GIS tools that they can use themselves to capture information and communicate it back to our responders. So it's not just a broadcast tool, it's actually a data collection tool too, so that we can close the circle on information sharing and everyone's on the same page. It's really easy to deploy and a very valuable tool that anyone can use, really. We're also going to show you two new tools to Esri. The first is Arcgis Mission, which Adam's going to show you how you can use that to prepare to dispatch your field workers so that they know the areas that they should be going to and for whatever activities, whether that's collecting more data to feed back into the system or in provisioning supplies and other services. He's also going to show you a new tool called Sitescan. Now, Sitescan is an end-to-end drone tool that allows you to plan flights, collect and process information, analyze that information, and even share it out directly through the web. It's a really exciting piece of technology that just came into the platform last year. He's going to show you how he used the Sitescan planning tool to actually implement control operations, leveraging the latest in drone technology. So with that, I'll turn it over to my colleague, Adam.
Thanks, Brendan. Hello, everyone. My name is Adam Pfister, and I'm a Senior Solutions Engineer on the Nonprofit and Global Organizations team here at Esri. Throughout the demonstrations that follow, I'd like to show you how you can create a powerful and impactful set of data, maps, and applications using ArcGIS. So let's get started with ArcGIS Hub. ArcGIS Hub is an easy-to-configure community engagement platform that organizes people, data, and tools through information-driven initiatives. Especially important in our scenario is the ability to engage with the local community. Here, we are looking at an example of a hub site that was put together to respond to the locust threat for a county in Kenya. At the top, we have a mission statement outlining the site's purpose. Next, we have a few configurable cards laid out on screen. Here we have two summary statistic cards that are data-driven directly from our analysis layers that were published earlier. These cards provide a clear and concise update on the total population and the total area affected by locusts. Underneath the statistics, we have an embedded web map pulling in relevant layers for a compelling visualization. Given that we want to hear directly from the community, we have embedded an ArcGIS Survey 123 form directly into the site. ArcGIS Survey 123 forms can include simple logic to hide or show questions based on previous answers, to validate data entry when collecting information like emails, provide an easy method to upload media, and to design a survey, it's as simple as dragging and dropping questions onto the form. As the results come in, you can view all the submissions in the Data tab and even details for each submission. The Analyze tab gives you a more holistic and aggregated view of the responses. These come in the form of charts, text, and maps. So once published, community members can fill out the survey and quickly provide feedback that is needed to effectively respond. And as surveys responses are submitted, they can be evaluated and put into the queue to plan the most effective strategy for support. Now that we have the community reporting on where they need assistance, let's use Sitescan for ArcGIS to define a priority area that will create a flight plan for control measure application. Sitescan for ArcGIS is a cloud-based drone mapping software designed to revolutionize imagery collection, processing, and analysis. Here we have Sitescan for ArcGIS on a tablet, and we're ready to create our flight plan. Let's give our flight plan a name and set the location to be near the field we want to deploy control measures for. Next, let's bring in the analysis layer that my colleague Rami created earlier using deep learning models that shows potential breeding areas of locusts. We can use this layer, shown here in green, along with the current locust swarm data represented by the points you see on the map, to lay out exactly where we want our drone to fly. Now the area is dropped into the middle of the map for us for our drone by default. However, we want to focus our control measure application to be close to this particular set of swarms. So let's go in and adjust that area now. Now our flight plan is defined. Using the terrain follow option within Sitescan, we can view our drone path in 3D along with the profile view to make sure that the plan created will be effective. We now have the community engaged in providing feedback through easy-to-use forms and a targeted drone solution to help deploy countermeasures against locust swarms. I'd like to turn now to another key part of the planning process, and that is preparing our field workers. For that, let's take a look at ArcGIS Mission. ArcGIS Mission streamlines operations while providing teams with situational awareness of an operating environment. All key mission data, such as chat messages, photos, and location tracks, is documented and stored for after-action review and playback. ArcGIS Mission enables teams to better understand their operations, make informed decisions in real time, and acquire new understanding from completed missions. The planning process begins in ArcGIS Mission Manager. To create a new mission, we'll give it a name, a summary, and we'll also set our geographic extent using our area of interest in Kenya. And then after the mission is created, we can continue on to fill in the mission details. So let's start by adding some team members. Next, we'll create a team that will be assigned to responding to the locust survey for our community members have been submitting. And now we'll open the mission. In our map, we can see the survey responses and the details for each. So let's create a task in which we want to have a team member visit the person who submitted this request for assistance. To do that, we'll give the task a name and a description, and we'll assign it a priority level and a due date. And then finally, select the corresponding location we want our team member to visit. The created task appears in our list here in Mission Manager, and then the team member can prepare for the visit. I'd like to pause now and turn things back over to Brendan, But don't worry, we'll continue this workflow in just a few minutes.
Thanks, Adam. To recap, so far we've seen how we can use ArcGIS Pro and the advanced analytic capabilities there to get a better understanding of where the locusts have been, as well as where they're likely to be. We've also used Arcgis Hub, Mission, and Sitescan to plan our activities. Now what I'd like to do is focus on how we can use location intelligence to put that plan into action. And we're going to do that by looking at a couple of tools. The first is ArcGIS Field Maps, and this is a brand new mobile data collection tool that just came out last year. And what we've done is combine capabilities that were present in multiple applications before to allow field workers to be able to collect and edit data, as well as retrieve information that's already being curated by the organization. And lastly, to be able to transmit their location and be tracked to any of the operations managers so that they can get a better understanding of where field workers are. This is a really powerful tool, right? Because it allows information to flow from the field up through country offices and all the way to headquarters for senior decision makers or even donors. And because Field Maps is part of the ArcGIS system, it's highly integrated with other applications like ArcGIS dashboards, for example. So we're able to take those data layers that we're collecting against on Field Maps and ingest those directly into dashboards and create these interactive products that visualize key performance indicators that might need to be tracked by different stakeholders. So we have this really integrated system that allows data to flow along it and presents information to different stakeholders all simultaneously. And to show you how that works, we're going to turn it back over to Adam Pfister and pick up where we left off in our last segment with Arcgis Mission.
Thanks, Brendan. As a quick reminder, we just got finished planning out some work for our field crews and assigned a task to a specific field member. This task was to go and visit a community member to determine what type of assistance would be needed. Using Arcgis Mission Responder on a mobile device, that team member now receives a notification that that task has been created and assigned to them. The team member and the field crew can review that task in their task list and then do things like change the base map to get to the imagery to get a better look at the area they will be visiting. Arcgis Mission also supports sending messages. A simple text message could be sent, or what's called a geo message could be sent that includes an area of interest that the team member needs to be aware of. In this example, the team member is receiving a geo message that will indicate an area of high flooding that should be avoided. Arcgis Mission can provide your field team with timely information to help them get their work done. Let's continue our workflow by outlining how our team member in the field will actually collect data once they have arrived at their location. ArcGIS Field Maps can provide that field data collection experience with ease. Field Maps is a full-featured mobile editing app, and that allows users to streamline the field workflows, empower your field workforce, access current data 24/7 online or offline, maintain transparency in field activities, and deploy quickly and easily. Now, the concepts behind how Field Maps works is pretty straightforward. You create and configure your maps, then you go out and collect the data in the field with map-driven forms. You can locate easily where you are or where your collection points are, and the ability to track your team to improve the overall awareness and safety of each member. Now we'll walk through how to create a form from a web map using the Field Maps web application. Let's start by configuring the web map we want to use. I can open up the web map directly within Field Maps and review the layers. In this web map, I have two layers. First, the survey responses from the community, and second, a polygon layer I want my field team to collect on that will represent the type of crop that is being assessed for damage due to locusts. In configuring the pop-up for my polygon layer, I can tell field maps which attributes I want the team members to collect. Here, we simply want the name of the crop type and the total area in hectares. Now we know that the map units are in meters, so we need to do a bit of calculation to get to hectares. And we'd rather not have to have our team members in the field doing that calculation each and every time. So let's take advantage of a powerful feature that Field Maps supports, Arcade. I can write a very simple Arcade expression that will take the area of the newly drawn polygon and convert it to hectares. Once this expression is created and my web map is saved, Field Maps will take care of the rest. Now, in the Content section, I'm able to determine what fields will appear in the mobile app for my field team. I want to have the different types of crops that can be collected set up as a template, and for the form, I would only need to have my crop type. There's a variety of formatting options to choose from based on the attribute, and for now, we'll make sure that this is a required question. I'll save the form and update the changes we just made. Field Maps also has several configuration options for offline data support, as well as desired and required GPS accuracy to ensure data quality standards are met. Now that the form is complete, let's see what it looks like for a user in the field. We're now looking at field maps on our mobile device and viewing the Locust survey response map we just authored in the Field Maps web application. First, let's change the base map to imagery to view our surrounding area. Field maps can collect data by adding points interactively on the device, or even by streaming your location as you move around an area. We'll capture this field directly west of our location. By clicking on the survey response submitted from a community member, we can confirm that this is where we want to collect. I'll tap and hold on the device to bring up a magnifying glass so I can get a precise starting point for our field. Then, after selecting a crop type, I can continue on by defining the boundary of the field. After I've finished, I'll submit the new area. Now take a look at the total area in hectares and notice that it was automatically populated for us. That was our Arcade expression at work in the background, converting the field areas meters to hectares. ArcGIS Field Maps is a perfect solution for streamlining data collection in the field. For the final step in our workflow, we need to be able to monitor the progress our field team is making from a variety of views. ArcGIS dashboards can give us those insights. The newly released ArcGIS dashboards is highly effective in delivering the right information at the right time to the right people. As you begin to work with dashboards, you find out it's easy to understand. It's ready to use. It's interactive. One widget can talk to one another. It's flexible to meet one or many needs. And it's configurable, requiring no coding at all. Dashboards can be created for anyone and for any industry. We're now looking at an operational dashboard that is configured to show how our field teams are responding to the community survey responses. On the left-hand side, a list widget is configured to show information from each survey response, including the type of aid requested, the name of the individual, their contact preference, and finally the status of our response. Is the response still open for assignment? Have we visited and assessed any damage? Or is the response closed out and completed? At a glance, we can quickly gain insight into the overall picture. The list widget is also interactive. As I click on each entry, the map will pan and then flash that location on the map. On the right-hand side, we have two indicator widgets that are configured to show the amount of food aid delivered in tons and the percentage of total seed supply that has been allocated to the community. I'm going to switch this dashboard into edit mode now and show you how easy it is to add a category selector at the top to let users easily filter survey responses based on their current status. Now in edit mode, I can add in a header widget that will include my dashboard's title. From here, I can also include a subtitle or a logo as well. For the category selector, I'll add that in within the header, and I'll choose to use the grouped values of the status field from the survey responses. A label will help identify what the selector will do, and will change the appearance from a drop-down menu to a button bar. And then finally, we'll add in the option to show all. This is looking good, but right now it won't do anything if the user clicks on it. So we need to wire up a few actions for that to happen. When a button is clicked, we want to filter both our list and our map widget accordingly. So now, when the user selects a status from the category selector at the top, the list widget and the map widget both filters accordingly. This was just a brief overview of what you can quickly and easily configure with ArcGIS dashboards. There's a lot more to explore and enable as you begin work on your operational dashboard. Thank you so much for your time, and we hope that these demonstrations have inspired you. We are excited to see what you all create in the future.
Thanks, Adam. You can really see how these tools can help generate that common operational picture, making sure that information is being shared to the right people in near real time. It's pretty cool how that all works and they're interconnected. So that's all we have for you today in this technical plenary. We hope that you were able to see some of the latest innovations coming from our Esri product teams and how they can support all different aspects of your response cycle, from understanding, planning, and acting. And we're really excited to see what you do with these tools and how you apply them to your own work. In fact, we want to hear from you. If you have any ideas you want to explore, please feel free to reach out. Also, if you just want to share some successes you've had, we want to hear about that too. We don't want the conversation to end after the conference ends today. We want to continue that through next year, when hopefully we'll all be able to meet again in Geneva. We've been working on a few initiatives to help us keep up that conversation. And for our next section, I'd really like to introduce you to Olivia Cottrey. He is our Director of Humanitarian Solutions at Esri, and he's going to be sharing with you an initiative that he's been working on, the Esri Humanitarian GIS Hub. Thank you.
Well, thanks, Brendan, Rami, and Adam for this really great demo. Especially like how the story demonstrates different GIS technologies and methods, and how they integrate with one another to support this one case study, in this case, the Locust crisis. Hello, everybody. My turn to have the pleasure of welcoming you to day 2 of this conference. My name is Olivia Cottrey. I joined Esri back in October last year as its Director of Humanitarian Solutions, following about 20 years in the humanitarian GIS field. We wanted to take these last 10, 15 minutes or so of the plenary to give you a quick introduction to the new Humanitarian GIS Hub that we've been developing these last few months. First, a little bit of context. So the Humanitarian Solutions team is part of a broader public safety solutions team. And that's the team that also manages the disaster response program, which you might be familiar with. It facilitates access to surge capacity licenses and tech support during emergencies. Now, our objective, the objective of a solutions team overall, is to make sure that Esri users in our sector get the most impact out of our tools and systems as possible. Now, probably many of us here today share the fact that our respective career paths have largely been driven by this belief that GIS tools have huge potential in supporting humanitarian response. The where question is everywhere when it comes to operational, strategic, and policy decision making. So whether it's by providing new insights, by enabling engagement, or simply providing a common geographic framework to otherwise very different types of data. We all know here, this is why we're here, right? We know that sort of GIS supports our operations. It provides this understanding of a humanitarian situation and helps plan and monitor action. Now, my role at Esri is, in effect, to pull the humanitarian threads that you'll find across various parts of Esri into a deliberate strategic framework. Starting with this vision or principle, that essentially risk to lives and livelihoods can be reduced thanks to better geographic thinking, thanks to leveraging the science of where to save lives and livelihoods. Now, the team's mission or overall objective, as I was just mentioning earlier, is really to enable the humanitarian community from local to global to achieve maximum impact with GIS. So how that breaks down is so through various consultations, we've identified 4 long-term objectives that we believe we can most usefully support the sector with. The first is localization. So we strongly support this notion that humanitarian effort should be as local as possible and as global as necessary. So supporting the localization of humanitarian effort by supporting decentralized development of capacity to leverage spatial intelligence in all its forms for humanitarian risk reduction. The second is risk reduction, or supporting the upstream work of reducing risk in the first place, and leveraging GIS to do this. So using GIS to assess hazards, to assess exposure to those hazards, providing information for risk-informed investments and land use. So here we speak very often of geodesign concepts. And there I think there's a lot of scope for us as a community to really apply geodesign much more. Thirdly, we want to work on putting the S back into GIS. So helping a sort of collective discussion around the systems nature of GIS, moving further away from GIS as a software to GIS as a system. So in the true sense of the word, so a system that supports business processes of an organization and engages all of its stakeholders. And finally, innovation, or actually the acceleration of the process by which new technologies can go from aspirational technologies to truly operational, practical technologies. So helping identify the use cases and the operational contexts that they are most appropriate for. Now, underlying all of this has to be a strong community of practice, engaged in a structured discussion, and learning process. So we as a community, we've expanded massively in the last 20 years, even the last 10 years. Geospatial thinking has really become core to most of what humanitarian actors do, and you've seen the amount for our work is increasing as a result. Now, it's been an organic expansion, which is great and ever more necessary. But it can also be a little chaotic. I don't know if you'll agree with me. So in a similar way to what we've experienced with this exponential increase in data availability, the increase in technological progress can be also quite daunting to navigate and to keep up with. So cutting across those 4 objectives that I just mentioned is also an effort to contribute to a more structured collective discussion and learning process to elevate the way that we use GIS and we leverage GIS to support the humanitarian effort. Now, concretely, the way we want to do this is through the Humanitarian GIS Hub. So the hub really is there to, first of all, act as a repository, an organized repository of good practice in humanitarian GIS, so organized around use cases that correspond to typical humanitarian operations. It's there also to promote this good practice by enabling the discovery, the efficient discovery and access to those resources and deployment of those resources. And finally, is there to help enhance that good practice through structured community discussion fora, through events that are targeted at specific and prioritized issues, through access to tailored learning tracks, and also through the identification of missing resources. If we organize our resources around our use cases, we'll more easily also find which of those resources are missing and need further developing. This is a quick schematic view of how we've organized the hub. I won't spend too much time on that because we'll be diving into it in just a second. I just wanted, though, to show you very quickly that the resources within the hub are organized by categories that were defined through a consultative process that we carried out over the last couple of years. So these include use cases organized around clusters, around information management phases, around technology types, and also around use cases around the different phases of the disaster risk reduction cycle. So you can see an example here, but we will in fact jump right in to that to see what that looks like. So if you allow me. So first of all, just to say you can access the hub via either of these two URLs. The first is actually our updated Esri.com humanitarian page, which provides a high-level overview of our support to the community and provides then links to the hub itself. And then you can access the hub directly also via that second link also. So let's jump into it. Here it is. This is the hub. Now, let me just organize myself here. So the first thing you can see is that you can create a free account to join the community. This will allow you, as well as exploring the content itself, to interact with the hub by, for example, requesting the development of solutions to specific use cases or proposing solutions that you would like to share out to the community. So we'll come back to that in a minute. The Hub Overview page is organized around two broad sections. So the first section organizes humanitarian GIS resources around these humanitarian use cases that I was telling you about. These are resources that you can access and download, and we'll come back to those. The second one is built around the 4 strategy objectives that I was mentioning earlier. And these will act, so these 4 objectives, you will recognize them here. So we've got the objective localization, systems thinking, disaster risk reduction, and innovation. Will act as a space to feature and follow various initiatives that support these objectives. So these could be Esri-driven initiatives or driven by third parties, by yourselves. So I'd like to focus, however, on the resources part of the hub. So you'll see here a first level of categorization. Under the card for inspiration, you'll find resources that are aimed at heads of GIS divisions, at operations managers, program managers who want to learn what GIS can do for their organizations. So the why and the what questions. Why do I want GIS? What can it do for me? What can it do for my organization? If we jump into this, you then see, so by clicking on that button there, it jumps you straight into this second level of organization, which allows you to choose to navigate those resources either via disaster risk reduction phases, programmatic area or cluster, or technology or methodology. So if we were to click on programmatic area or cluster, we would get then to this gallery, which allows you to then filter these resources by the cluster that you're interested in. Now, the next card is solved, but we'll come back to that one. This is the one I want to focus on in a minute. This one is aimed at GIS professionals who want to find quickly deployable and reconfigurable templates for specific use. So these are literally one-click deployable resources. So we'll come back to that in a minute. The next card here is a card around the learning tracks and learning modules. So these compile learning tracks that can be filtered by various categories again. So by clicking on this learning card, you can get to this learn.arcgis.com site, which again allows you to filter these pre-configured learning tracks by various topics. So if we go back to public safety here, for example, and then we want to take lessons, type of lesson, and then you've got various technologies and capabilities that you can be filtering by. So we'll be building out these learning tracks with those specific humanitarian use cases in mind. There is a card called Operational Services here, which you can see, and this compiles resources that were stood up either by Esri, for example, the disaster response program of Esri, but also by third parties for specific events that are ongoing. So this is where you'll be able to find Esri or third party GIS services, data services, analytical services, platforms that are stood up for specific events. We also have a data section that compiles data providers relevant to the humanitarian sector, as well as initiatives, discussions around various data topics like data ethics, for example. And finally, a community section that points to Esri's new community site, right here. That's the former GeoNet, for those who were active on that. And so that community site, again, allows us to structure community discussions around different humanitarian use cases. Now, let's just dive back into that solutions section here. So you'll see, once again, the next level of the solutions section allows you, once again, to choose your categories, either by the disaster risk reduction phase, or by the information management phase, or by technology and methodology. We will dive into the Drr categorization. So once again, what you see here is a gallery that allows you to filter deployable resources by various use cases, those use cases that I mentioned that were defined through this consultative process over the last couple of years, and that filter out deployable solutions according to the use cases that you're looking for. And you'll have noticed that some of these use cases are still empty. Now we're in the process of populating the hub, but there will be use cases that simply don't have convenient solutions. And so there is also a form down here that allows you to suggest or propose solutions that are missing, or share a solution of yours back with the community. So here you can request a new solution that you see is missing, and here you can share a solution that you have that you think would be useful. And you can submit that, and we'll then get in touch with you to discuss how to go about putting it up onto the hub. So the hub is now live. Please feel free to visit, create your own account on it. See it as a living space that will constantly evolve with your feedback. We'll be organizing a number of events and webinars, so not only around the topics contained in the hub, but also around the way the hub itself is organized, so that we can continuously improve it, make sure that it's as useful as possible, as relevant as possible. So very much looking forward to seeing you there. We are going to jump back into our presentation. I'll close off the plenary session now by giving you a bit of a glimpse of what we're going to be looking at today. So after a short 15-minute break, we'll kick off with the day's first session. You'll have the choice between two technical workshops here. One will focus on user-centric design. You'll hear about how to engage the stakeholders of your organization to a true process of GIS systems design and implementation. So very much aligned with this notion of systems thinking that I was mentioning earlier. The second parallel session is on the application of new GeoAI capabilities in ArcGIS. So this time, speaking more to our objective of innovation acceleration and showing how to put AI into operational practice. Both these sessions will be what we call simulcast. So they're recorded sessions, but you'll be able to put questions to the moderators through text, and these will be addressed as the session progresses. After that, we'll be hearing from a number of our peers and some of you in the audience here on the application of GIS to resilience building during an Ignite talk session. So you'll be hearing from a group called Resilience Mappers in Uganda, who are conducting a crowdsourcing mapping project to literally put informal settlements of Kampala on the map. You'll be hearing from the UNGSC on how maps support UN operations to build sustainable peace, from the Aga Khan Agency for Habitat on hazard vulnerability and risk assessments, from UNISAT on using remote sensing to build resilience in the small islands nations, and finally from WFP VAM on GIS for asset impact monitoring. So really looking forward to these sessions. And again, these speak to one of our objectives, which is applying GIS to upstream risk reduction in various ways. And we will round off the conference with a mapathon. So we'll have the pleasure of having the Humanitarian OpenStreetMap team provide us with a briefing session for a mapathon that will run over the next few days. And you'll hear also from our colleague, Dean Kensuk, at this session, who will provide an update on the tools in the ArcGIS environment that allow you both to leverage OSM data in ArcGIS, but also use ArcGIS tools to contribute back to OSM. So I hope you'll join in also for our closing session with Einar and Carmel, who will provide a final send-off at the end of the day to summarize these last couple of days and look and maybe dream ahead a little bit. So thank you very much for joining us today, and enjoy the day.